Chapter 6, Chemical Composition. Sodium is an important mineral that your body needs, but if you get too much of it, it's harmful. And that's actually the case for anything. Too much is harmful. So when we consume sodium, it's usually in the form of sodium chloride, which is table salt. It's important, it regulates your body fluids, but if you get too much, it can cause high blood pressure. Here's an illustration of sodium chloride. It's present in lots of things. So the Food and Drug Administration says that you should consume less than 2.4 grams, which is 2,400 milligrams of sodium per day. Does that mean you shouldn't eat more than 2.4 grams of salt, sodium chloride? No, that's not what it means, because the mass of sodium is not the same as the mass of sodium chloride. Because in a gram of sodium chloride, there is not a gram of sodium. There is sodium and chloride, and they both add up to 1 gram. So how many grams of salt could you eat and not go over that limit? Well, we're going to learn how to calculate stuff like that. The composition of sodium chloride is given by its formula, NaCl. For every 1 sodium ion, there's 1 chloride ion. The masses, though, are different. The mass of a chloride ion is significantly more than the mass of a sodium ion. So we can't say that, well, half of it's sodium and half of it's chlorine. Half the ions are sodium ions, but the sodium ions weigh less than the chloride ions. So we have to calculate the composition of it to find out the amount of the whole compound. So we need to look at the amount of the constituent element, the sodium that we're interested in, to figure out how much salt you could eat and stay under the 2.4 grams. This sort of a calculation is done in many different situations. A mining company, they're pulling different ores out of the ground. An iron ore is just a compound, an ionic compound that contains iron. It might be iron with oxygen, it might be iron with carbonate. There's all kinds of different ones that are out there, just naturally occurring. So the mining company wants to know, well, if we need a ton of iron, we're going to need more than a ton of iron ore. How many tons do we need? This is sort of calculation. Freon looks like this, Freon 12. And this isn't great for the atmosphere because it's got chlorine in it, and it goes up in the atmosphere and messes with the ozone layer. We need to know, though, how much chlorine is in a given chlorofluorocarbon, because there's also carbon and fluorine in here. And so how do you know how much chlorine is in there? You have to look at the composition. So we can calculate the amount of an element using the chemical formula and the formula mass or the atomic masses.